Check it.
Okay, welcome back. Today we're going to be talking about rational exponents. So what's a rational exponent? Well, the word rational comes from the word ratio, which is a synonym for fraction. So rational, whenever you hear the word rational in mathematics, think fraction. A rational number is a number that can be written as a fraction, like 5/7. Okay, that's a rational number. A number that is a decimal that goes on forever and never repeats, like the decimal you get when you square root, like, I don't know, 7, for instance, is not a rational number because you can never write this as a fraction. Okay, it would be a crazy decimal that goes on forever and never repeats. So in order to have a fraction, you have to have a whole number over a whole number like this, or something that could be written this way at least. So ratio is a synonym for fraction. Rational means a fraction, basically. So rational exponent is another word for fraction powers, because exponent means powers, right? So if you want to explain it to somebody who doesn't know what we're talking about, fraction powers. So up until now, every power you've ever worked with has been like x to the 4th power or something like that, whole number. Well, it is possible to have x to the 1/2. It is possible to have x to the negative 2/3. Okay, and that's what we're going to be dealing with here. This is called a rational exponent. That's called it's a negative rational exponent. And turns out rational exponents are directly connected to roots. Okay, and they are really, really closely connected. In fact, you can jump back and forth between radicals and rational exponents very easily and very quickly. So a power, okay, when you write your root as a power, when there's a fraction here, the root, if you have let's say you have a third root of x to the 4th power here, for instance. This is a third root, and it's x to the 4th power. If you want to just change this to a rational exponent, you're going to make a fraction where the top is the power and the bottom is the root, just like I have written here. So this is going to be x to the, well, what's the power here? The power is 4, and the root is 3. And there you go, x to the 4/3 power. All right, so let's just make that 4/3 a little smaller and a little bit higher so it looks like a power rather than a fraction. And there you go. So it's pretty simple. Just make sure the power's on top and the root's on the bottom. Now, an easy way to remember that is the root of a tree is at the bottom of the tree, right? It's not on the top of the tree. So the root of something tends to be at the bottom. And, well, as sometimes in life, power is on top. So anyway, okay, a little dark there, but the root is the bottom number, power is the top, and that creates a fraction, which is your rational exponent. It's really that simple. In the homework, they're going to ask you to do a lot of jumping back and forth between rational exponents and radicals. Okay, so these are in radical form, meaning they have this radical symbol, right? And they want you to change them into rational exponents, exponential form. And down here, they give you exponential form and they tell you to write it in radical form. So all we're going to do right now is just go back and forth between the two forms just to show how easy it is. So once again, your letter here is x, that's your variable. And you're going to make a fraction where the power is on top and the root's on the bottom. Well, the power here is 7, power on top, the root is 3, root on the bottom, and you're done. It's that quick, okay? How about this one? This is x to the 3/5. Now, if you remember, when we were simplifying radicals, we were dividing this number by this number. So it actually makes a lot of sense that this number, when you're dividing something by something, this goes on top and this goes on the bottom. It makes perfect sense. So if you had x to the 4th second root, this would be x to the 4/2, which would be x squared, right? So this is not something new. The only thing is it looks like a rational exponent when this doesn't divide by this right away. We're not asking you to simplify, because if we were asking you to simplify, for instance, let's say you had x to the 7th 4th root, right? 7 doesn't divide by 4, so what do? We come down to 6 and down to 5 and down to 4, right? We break it down like that and do the 4th root of each one. But we're not asking you to do anything like that. Right now, all we're doing is changing it into a power. Okay, here we have multiple factors to chop up. So chop it up first. And you have the square root of x to the 3rd, you have the square root of y to the 5th, and the square root of z. Now, each one of these has that invisible 2 here, right? And once again, power over root. So this is x to the 3/2, y to the 5/2, And z to the, well, there's also an invisible 1 here that we don't write. So if you don't have a power, you assume it's a 1. And this becomes z to the 1 over 2. Translation, anything to the 1/2 power is just a square root. All right, something that comes in really handy. And there you go. Now we're going to go the other way. Now we're going to take exponential form and write it in radical form. They're going to ask you to do this on the homework as well. Okay, so once again, the bottom number is the root, like with a tree. The bottom is the root, and the top is the power. And you want to write a radical now that has those properties. So there's your a. You're taking the third root of that, so third root, and you're taking the second power. The power goes there. There you go, you're done. So if it looks like there were a lot of homework questions tonight, a lot of them are like this, under 20 seconds. Okay, so, or 10 seconds even. All right, so how about this? This is the second root of x to the first power. Okay, second root, meaning square root of x. First power means there's no power. Okay, so when the top number is a 1, for all intents and purposes, there's no power because the power of 1 doesn't do anything. So you have that. And this right here is also the second root, so it's a square root, of y to the third. And since they're both square roots, we can combine them into one radical, and there you go. This one requires a little bit of algebra first. So we have a bunch of powers in here and a power outside. So this is power of a power. And with power of a power, you know, like for instance, if you have x to the 5th power to then the 3rd power, you don't add the powers, you multiply the powers and you get x to the 15th, right? Because really this is x to the 5th times x to the 5th times x to the 5th, and you add those 5, 5, and 5, you get 15. So here you have power of a power as well, because this power applies to all 3 of these. So what you get is a to the 2 times 1/3 is 2/3. B times, 3 times 1/3 is actually just 1, which we don't have to write. And c to the 4th to the 1/3, 4 times 1/3 is 4/3. Now they told us to give the answer in radical form here. So how do we write each one of these in radical form? Well, I just realized something. Okay, so this would have been 3/3 if I didn't reduce it, right? Like that. And if they're all the same root, you could put them all in the same radical. So this would all be a cube root here, and you get a squared, b to the 3rd, c to the 4th. Okay, this next one's a similar problem. Well, once again, we're multiplying power of a power here. So 4 times 4/3 is 16/3. 5 times 4/3 is going to be 5 times 4 is 20, so 20 over 3, 20/3. And 6 times 4 is 24, 24/3. Now 24/3 is 8, but I'm not going to simplify it because my goal here is to get them all into the same radical. So x to the 16th, y to the 20th, z to the 24th, and I'll box that. Even though, yeah, I could simplify this, that's not the point of this question, so I'm not going to go ahead and do that. We're just writing it in radical form. Okay, so now we're going to work with numbers. We worked with letters. We're going to work with numbers. Now, once again, you have a power on the bottom and a power on the top and the root on the bottom. But another thing that can also come up is that you have a negative in your exponent. Now, we've learned about negative exponents already. A negative exponent means to flip something upside down. So for instance, 5 to the power of -1 is 1 over 5. You flip it upside down. Or if you have 2/3 to the -1, it'll be 3 over 2. Now notice I didn't do this. I didn't write 2 to the -1 over 3 because that would just mean 1/2 over 3, okay? I put the fraction in parentheses. So yeah, we already learned that a -1 power means flip it upside down. So now there are 3 ingredients here. There's not just a root and a power to think about, but there's also a flip. When evaluating numbers, I want you to do them in this order. First root, then power, then flip. Okay? Because 90% of the time, that's the easy way to go. All right? And you don't need a calculator. So what it says here in the instructions is do this without a calculator, give an answer with no exponents in it. Okay? Give an answer with no powers in it. Can you do this without a calculator? Yes, you can. Okay, believe in yourself. If you do this with the root power flip method. Okay? Copyright Abdul Hadi 2006. Once again, this is a joke. You want to start with the root because if you start with the power, your numbers will get really big and you'll need to reach for a calculator. It'll work either way, but we want to do the easiest thing here, not the hard thing. So take the root first, then take the power. And the last thing you want to do is worry about flipping it upside down, because flipping upside down creates fractions, and you want to do that after you're done with the math. So we come over here. We have a root of 2, second root. We have a power of 1, which means no power, no step to do, rather. And there's no flip. There's no negative there to flip. So really all we're doing here is a root. That's it. There's no power, there's no flip. We're just doing the second root of 81, which is the square root of 81. And the answer is 9. Nice and easy. Don't need a calculator for that, I hope. Here, we do have a root. All of these have a root. But we also do have a power. No flip. So once again, the order, if you do 100 to the third power first, it's 100 times 100 times 100, which is 1,000,000, right? You don't want to get 1,000,000 and then try to square root 1,000,000. So do the root first. Second root of 100 is the square root of 100. Then after you do that root, then do a third power of that. So the way I want you to show the step is, show me the first step and then put parentheses around it and show me the second step. And then when we get to the root power flip, there's going to be 3 steps down here. But anyway, once you set it up like this, the square root of 100 is just 10. I hope you know that without a calculator. And then what's 10 to the third power? What's 10 times 10 times 10? Well, we all know that powers of 10, all you do is, that's how many zeros you have. So it's a 1 with 3 zeros, and it's 1,000. There you go, no calculator necessary. Here we have a third root and a second power. So the first thing you do is the third root of 27. Simple number. Put parentheses around it. Now take it to the second power. All right, there's your setup. That's worth a point right there. Now do the, PEMDAS, or start with the inside the parentheses here. So the third root of 27 is 3. 3 times 3 times 3 is 27. We've learned that a lot over the last couple of lessons. And then you square that and you get a 9. Boom, done. No calculator necessary if you do this the right way. These next ones have negative powers in them. So not only is it root and power, but you also have flip. And once again, root, power, flip is the order you want to do this in. So root, then power, then flip is almost always the path of least resistance. So you want to do this the easy way. That's what you want to do. Because check this out. You have a fourth power here. 8 to the fourth power is huge. You're not going to be able to do that in your head. 8 times 8 times 8 times 8 is a very big number. Okay? So don't do that. Root, power, then flip. What's the third root of 8? Write it down first. Third root of 8. Then take that to the power of 4. And there's a negative here, so we're going to flip that. And the way we show that we're going to flip that is put another set of parentheses around that and put a little -1 here, because that means flip. Now, if you think about this, when you multiply the -1 times the 4 and divide by 3, you get -4/3. So this makes complete sense, hopefully. Now, PEMDAS, you start with the innermost set of parentheses. What is the third root of 8? 2 times 2 times 2 is 8, so that's a 2 right there. So now you have 2 to the fourth power, and then you still have to do the flip after that. What is 2 to the fourth power? 2 times 2 times 2 times 2 is 16, to the -1 now. And then finally, you flip it. You get 1 over 16 and you're done. So 8 to the power of -4/3 is 1 over 16, and you didn't need a calculator. And you didn't use any decimals, because you're not allowed to use any decimals here. Okay, let's root power flip this one. Let's RPF this one here. So we have a 16. We're going to take the fourth root, then we're going to take the third power, and then we're going to flip it. This setup right here is worth a point. I need to see this, and if you don't do it, you don't get the points for it. So be forewarned. Now, what is the fourth root of 16? It's 2. To the third power, to the -1. Okay, what is 2 to the third power? It's 8 to the -1. And then 8 to the -1 is just a flipped 8, so it's 1/8, and we're done. Bet you didn't think 16 to the -3/4 power would be so simple to do that you can do it without a calculator before you saw this, but now you can do it. Okay, 1,000 to the -2/3 power. Okay, once again, root first, then power, then flip. So what's the third root of 1,000? Now, we just did a problem that kind of answers that question right over here, so hopefully you don't need a calculator for this part. Then a second power, and then finally, there is a negative here, so -1 for your flip. Show me that setup, it's worth your first point. What's the third root of 1,000? What times itself 3 times is 1,000? Well, we just did a few minutes ago, it's 10. 10 times 10 times 10 is 1,000. Now you're going to square that 10, and then you're going to flip it. Well, what is 10 squared? It's 100. 10 times 10 is 100, right? Oops, you don't need parentheses anymore. Flip that, and your answer is 1 over 100. No decimals, easy peasy. There it is. Okay, so most of this is multiplication here. So we already know that when you multiply two powers of x, like let's say x to the third times, I don't know, x to the fifth, you add the powers and you get x to the eighth, right? So this is no different, but they just happen to be fractions. So you're going to get x to the 3 halves plus 5 halves. Now, luckily, they're already common denominators. 3 halves plus 5 halves is how many halves? It's 8 halves, right? 8 over 2. And 8 over 2 is just 4. So there's your answer. How about here? Well, here, once again, you have a common base. When you multiply two things of the same base, you just add the powers. So this will be a to the whatever 4/3 plus 1/2 is. The thing is, 4/3 and 1/2, they don't have a common denominator, so you can't add them right away. You have to find the common denominator. So let's go back to middle school for a minute here. What's 4/3 plus 1/2? Common denominator for 3 and 2. Since they have no factors in common, you just multiply them, and you'll get 6 as the common denominator, right? And now the question is, what are the top numbers, right? So what do you multiply by 3 to get 6? You multiply by 2, you double it. So you have to double the top as well, and you get 8 over 6. What do you multiply by 2 to get 6? 3. So if you triple the bottom, you have to triple the top, you get 3 6. So 8 6 plus 3 6 is how many 6? It's 11 6, right? So your answer is a to the 11 over 6. And there you go. Now here we're dividing. And with dividing, you guys hopefully remember that you subtract the power. So let's say you have x to the 7th divided by x to the 4th. You subtract 7 minus 4 and you get x to the 3rd. And you also could have the opposite. You could have x to the 4th divided by x to the 7th, and you get x to the 4 minus 7 is negative 3, right? And of course you can't leave it as a negative, so you flip it and you get 1 over x to the 3rd. So a quick review of properties of powers from earlier in the year, this year. So here we have z to the 5/9 divided by z to the 2/9. You're just going to get z to the whatever 5/9 minus 2/9 is. Well, they're already common denominator, so 5/9 minus 2/9 is 3/9, z to the 3/9. And you must reduce everything to lowest term, so this fraction, 3/9, becomes 1/3. So there's your full credit right there, as long as you go all the way down. Now this one, you get w to the 1/2 minus 1/3. There is a common denominator needed in order to subtract 1/2 from 1/3. So we'll come over here, 1/2 minus 1/3. Common denominator would be 6 and 6, right? You triple the bottom, so you triple the top. You double the bottom, so you double the top. So 3 6 minus 2 6 is 1/6, and you get w to the 1/6 power, and you're done. So operations with rational exponents, you just, like any other thing, you add and subtract normally. Okay, now we have learned that you can only multiply two radicals if they're the same kind of radical. Like for instance, you can only multiply a cube root times another cube root. So if that's 7 and that's 3, you get the cube root of 21, right? That sort of thing. Same thing with dividing. You can only divide two radicals if they are the same root. So this is a cube root, this is a cube root, and the cube root of something over the cube root of something just becomes the cube root of the fraction, 7/3, like that. There you go. Or in the case of the cube root, let's say 25 over the cube root of 5. This becomes the cube root of 25 over 5, and then you can simplify the 25 over 5. What is 25 over 5? It's 5. And there you go. There's your answer. So as long as they're the same root, okay, you can multiply and you can divide and you combine them in any way you want to. The problem with all these is that they're not the same root. The top is a 4th root, the bottom is a square root. The top is a cube root, the bottom is a square root. The top is a 4th root, the bottom is a cube root, right? So these are not the same kinds of roots, so we can't just divide. We have to have some other strategy. So the strategy here is to find a common base, okay? The common number inside the radical. So you might say, well, how's that possible? Well, it isn't possible all the time, but for all these problems, it is possible. Here's what I'm talking about. You're going to use a factor tree, and you're going to find a number that's going to be common inside for both the top and the bottom. And hopefully it's really clear on this first one that this 25 is just 5 squared. So what you have here is, you can rewrite this as the 4th root. Instead of 25, you can write it as 5 squared. Okay? I didn't bother doing the factor tree, but there you go, 5 times 5. And then the bottom is also something with a 5 inside. Once you do that, check this out. You can now write these as fraction exponents, as rational exponents. So this becomes, on the top, 5 to the 2/4, which we will reduce. And this becomes 5 to the, well, this is a power of 1, invisible 1, invisible 2. So this is 5 to the 1/2. And reduce these to lowest terms. This is 5 to the 1/2 over 5 to the 1/2. It's a fraction over itself, so it equals 1. And you're done. Okay. How about this one here? 27. If you factor tree 27, you get 9 times 3, and you get 3 times 3 times 3. So 27 is 3 to the 3rd power. So you can rewrite this one as the 3rd root of 3 to the 3rd power, and this one is going to be this is already the square root of 3. They have the same number now, the same base, okay? They have different powers, and they have different roots, but they have the same base, and that's the important thing. So now we're going to write these as fractions. 3 to the power of 3 over 3, well, that's just 3. There's 3 over 1, power of 1 now, right? And this is 3 to the 1/2. 3 to the 1, invisible 1, and there's an invisible 2 here, so 1/2. So what you have here is, just move this up a little bit. You have here is 3 over 3 to the 1 over 3 to the 1/2. Now we don't usually write the 1, but we want to subtract the powers. So we're supposed to subtract 1 minus 1/2 here. Well, I don't think you need to find a common denominator to do 1 minus 1/2. 1 minus 1/2 is 1/2, right? And there you go, 3 to the 1/2. You could also write this as a radical, which is the square root of 3. The answer key in the book might write it either way. Okay, here. Can we find a common base for 32 and 2? Well, you come over here, you make a factor tree. 32, I don't know, 8 times 4 might work. This is 4 times 2. This is going to be 2 times 2. And this is going to become 2 times 2. And these three are prime, 2, 2, 2. So 32 is 2 to the 5th power. See, 5 2's. So this becomes the 4th root of 2 to the 5th power over the 3rd root of 2 to the 1st power. Write them as fraction powers, rational exponents. This becomes 2 to the 5/4, and this is 2 to the 1/3. And as we did on our recent problem, we just subtract the powers. So what is 2 to the 5/4 minus 1/3? Well, we're going to need a common denominator. So what's a common denominator for 4 and 3? Since 4 and 3 don't have any factors in common, you can just multiply them. You get 12, like that. What do you multiply 4 by to get 12? You multiply it by 3, right? Well, that means you have to multiply the top by 3, and that means this right here will be 15. And you multiply the bottom by 4 to get 12, so multiply the top by 4, and this will become 4. See, you're multiplying by 3 over 3, which is a 1. You're multiplying by 4 over 4, which is a 1. So you're not changing the fraction, you're just changing the way it looks. So we now have 15 of these things called 12ths, 15 12ths, minus 4 12ths, which is 11 12ths. So you get 2 to the power of 11 over 12, and we're done. So what was impossible before is now possible because you know about rational exponents. Before, you couldn't divide these because they were different roots. But by getting the common base, you can change to rational exponents, and it's possible. All right. This last part is called rationalizing fractions. We did rationalizing with radicals already. So rationalizing said that you cannot have in your denominator any radical symbols. Okay? So we used conjugates and other radicals to get rid of the radicals. The problem is, or not the problem, but the issue with this is that this doesn't look like a radical, but it is one. Okay? This is the 3rd root of x to the 1st. This is the cube root of x. That is that. So that's a radical. It doesn't look like a radical, but just be forewarned, anytime you have a fraction power, that's a radical, okay? Because if there's a fraction power, that denominator is the root. If there was no root, you'd have a whole number power. You'd have like 5, no denominator. But as soon as you put it over any number other than 1, and why would you do that? You wouldn't write a 1 there. But as soon as you put it over any number, like 2, boom, that's a radical. That's a square root of x to the 5th. So the fact that there's a fraction power in your denominator is a problem. You can't have a fraction power in your denominator. And so we're going to learn how to rationalize our denominators. So we learned for square roots, with radicals, we learned some tricks for square roots. They don't apply for all roots though. What do you do when you have a 3rd power, 1/3 power here? Okay, so you don't want to change this to a radical. You don't want to have this because we don't know how to deal with this. This is actually more complicated than dealing with it this way. So that's why we're doing this now. We only know how to rationalize square roots and this one with conjugates, right? We did that, just a review real quick from the last lesson. You multiply this by the same radical and you multiply this by the conjugate on top and bottom, right? That only works for square roots. It doesn't work for third roots, fourth roots, fifth roots in the same way. So if you have a 1/3 power, that's actually a third root. Okay, you can't just multiply it by another third root. It just doesn't work. You'll get a 2/3 power, which is not going to help you. So here's what we're going to do. We're going to realize that we want to get rid of the fraction here. To get rid of the fraction, you need to make this fraction here into a whole number. So it won't be a fraction anymore, right? The way to make a fraction no longer a fraction is to get rid of its denominator, which is to make it a whole number. So how do you make 1/3 into a whole number? Now we're going to multiply the top and bottom by something, but what will we multiply by to get this to become a whole number? So this may not be obvious, but x to the 1/3, 1/3 is definitely a fraction. X to the 3/3, that's a whole number. That's a 1 right there. Okay? So how can we get the 1/3 to become 3/3? Well, you need to add 2/3 to it, right? So here's what we're going to do. We're going to multiply the bottom by x to the 2/3. Whatever it takes to make this 1/3 into a whole number, which is 3/3. And we'll do that on the top and we'll do that also on the bottom. So we'll have to do the top and bottom the same so that this whole fraction ends up becoming just a 1 and is not changing the value of the original problem. So when you do x to the 1/3 times x to the 2/3, you have to add the powers. 1/3 plus 2/3 is 3/3, which we all know is 1. So that's just an x right there. And on the top, you have 5x to the 2/3, and you're done. There you go. The bottom is no longer a radical. It's no longer a fraction power. So you've rationalized this. And that's all it takes. All you have to do is find the power that makes this a whole number. Now, this next one here, the last example we're going to do, something like this, I think you're probably better off just writing it as radicals because it is a square root. Like I said, for square roots, radicals work great. So if you do see a 1/2 power, that's a square root, right? Second root, first power. You could just write this as the square root of x plus 2 over the square root of x minus 2. And then we did these problems in the last section, right? All you do is multiply by the conjugate, top and bottom. Make sure these match so they equal 1 when you divide them, right? And what you get, radical x times radical x is x. Negative 2 times 2 is negative 4. And there you go. The bottom is all done. The top, of course, you're going to have to multiply all the way out. So radical x times radical x is x. Radical x times 2 is 2 radical x. 2 times radical x is another 2 radical x. And 2 times 2 is 4. So your final answer is x. This becomes 4 radical x plus 4 on the top. And the bottom is just simply x minus 4. So the moral of the story for this one is that there are some things that are easier as radicals. So this one just changed to radicals and it's exactly the kind of thing you've already done before. Okay, we're done. See you at the next video.
Check this.